Our next speaker today is Ihor Kendiukhov. He's based in Berlin. He has a background in quant finance, AI, as well as deep tech. Ihor leads the big data and algorithmic analytics department of Deep Knowledge Group and Deep Pharma Intelligence by association. His educational background is in economics and biochemistry, and he does have experience as well in venture capital, with a focus of companies active in the spaces of AI, biotech, longevity, IT, and fintech. Ihor is also the author of a number of scientific papers on the subjects of biomarkers of aging and longevity, as well as finance and macroeconomics. Ihor, the floor is yours. I quite look forward to your presentation today.
Thank you very much, Branka, for this insightful and comprehensive introduction. And the topic of my talk is algorithms and data for deep tech investment analytics. Well, as it was already mentioned, basically the AI pharma market is booming, and the growth is measured by the thousands of percent annually. And in the case of publicly traded AI and pharma companies, we have the growth that is measured by hundreds of percent annually. And in order to deal with all this data, in order to extract value from it, especially from investment standpoint, we have developed Deep Pharma Intelligence Big Data Analytics dashboard. And this dashboard covers almost all entities present in the industry. Namely, there are more than 280 companies and more than 700 investors and more than 100 deals. Basically, it consists of an pharma industry landscape, industry database, and our analytical reports, which are both open access and proprietary. And when we were advancing this project, we have developed a similar platform for the longevity industry, which is much more comprehensive and which is much more detailed. It covers almost 20,000 of companies, and altogether it has more than 4 million data points, whereas in the case of AI and pharma industry, we have 40,000 data points. So it means that the data set is larger by an order of magnitude or even more. And here, the abundance of that data, the flood of data has enabled us to really implement very advanced artificial intelligence and especially deep learning tools. And what we have applied for deep pharma intelligence and for drug discovery landscape was enhanced in the longevity investment dashboard. And the most applicable for the analysis of the AI and pharma deals feature is our interactive online AI-based SWOT analysis system, which covers most of the deals in the AI and pharma industry. Basically, is this an automated AI-based data-driven way to evaluate AI and pharma deals quantifiably, tangibly, and very fast and precise. Basically, we analyzed about 200 various data points and combined them in 12 vectors of the business development, or let's say efficiency of the deals. And each this vector is basically a set of parameters, some mathematical equation that with appropriate weights and mathematical transformations that returns one single value, one single scalar for each aspect of the deal. And by doing so, we can not only see the strengths and the weaknesses of each deal, of each company entering the deal, but we can see as well the level of harmonization of the specific deal, the level of the balance between various aspects of its development. And our open access version of the algorithms is presented here. So it's not a black box issue. Of course, we have proprietary algorithms and proprietary SWOT analysis methodology, which is much more deep than presented here. But the first layer of this methodology is visualized on the slide, and it's open access. Basically, all you do not need to dive now a lot into the specifics. It's just point that various colors, various lenses of the borders represent and reflect various mathematical transformations and connections inside the algorithms. And considering the abundance of the data and the level of the speed of the development of algorithms, we are doing this in such a way that when we are developing new level of analytics, we just put our previous analytics online and just allow everyone to see the SWOT analysis results on our websites, which you can observe on the deep farm intelligence big data analytics dashboard in the industry database in SWOT analysis section. Another feature which is very important and very relevant for the analysis of the AI and pharma deals with pharma and tech corporations is competitor matching. It basically means calculation of the distance between companies in terms of their business development. And it utilizes both conventional clusterization tools such as k-means algorithms and much more advanced tools such as various methods of unsupervised machine learning. And it allows us to find the closest companies to some specific companies, or let's say the closest competitors. And when we're analyzing a deal, we can see what similar companies we have and what differentiates this specific company from other ones. Another tool which can be applied for this purpose is interactive network diagrams, which enable us to define a company or investor in the context of the existing industry infrastructure. Basically, it analyzes funding rounds, collaborations, team networks, and various aspects of business development in order to see the connections between this company and other companies. And when we are trying to analyze a deal the company enters, we need to basically see what are the deals or what are the, generally speaking more generally, collaboration does this company have, and how all these collaborations fit in the context of this new one. Basically, almost all our technologies, especially what relates to AI, machine learning, and more conventional maths, which applied for our projects, are listed here, and they can be categorized into four main parts. It's that relate to our SWOT analysis, data aggregation, forecasting, and clusterization and competitor analysis. Whereas for the SWOT analysis, we apply more or less conventional tools such as just polynomial formulas and linear algebra. For data aggregation and for forecasting, various architectures of deep neural networks are applied, and the same is done for clusterization and competitor analysis. And another important feature of the analysis of the deals is the analysis from the standpoint of large pharma and tech corporations which are entering the deal. So previously we were talking kind of more or less from the standpoint of this AI startups and the technological and financial indicators that making them more or less attractive for the deal. Whereas now it is more about large corporations, publicly traded corporations that enter the deals with the startups. And here stock market analysis is crucial. And we apply here both conventional econometric models and advanced artificial intelligence and deep learning tools, including first and foremost neural networks with LSTM layers and recurrent neural networks. Also, we apply various stock market simulations that enable us to test various trading strategies and investment principles. It is also important to know that financial analytics here is combined with technological evaluation of the companies and fundamental analysis of their cash flows. Generally, we have the following in regard to the deals analysis. We have the following services for companies and investors. These services relate mostly to the deep SWOT analysis of the deals and benchmarking and ranking of the startups entering the collaborations. From the standpoint of investors, or from the standpoint of large pharma and tech corporations entering the deals, it can be considered as investment target selection and the analysis of potential deal targets and investment targets. Another important feature here is the search for potential competitors or matching with partners. So with that, I'm closing my presentation, and I'm thanking you for your attention, and I'm open for your questions now.
Thank you very much for that, Ihor. Quite in-depth presentation indeed. I'm curious to what extent the various analytical technologies and approaches that you're using for the AI and pharma sector might be repurposed and reapplied to other deep tech industries, as well as how exactly you're avoiding the so-called black box problem in the development of your algorithms.
So yeah, basically, we have tried these approaches. We initially developed these approaches for AI and pharma industry. It was our first iteration. And as I mentioned already in the presentation, so we have applied it much more deeply for the longevity industry. And we are trying to do so in other deep tech industries as well already by now. So namely in neurotech, space tech, and fintech. And basically, I think it is quite applicable and general approach for almost every deep tech industry. There is abundance of data, there is enough data. And I would say that among the industries I mentioned, the most applicable is the longevity industry, just because of the abundance of the data. And because of this, we can really extract value from advanced deep learning algorithms, because for example, the difference between just simple regressions and neural networks with various architectures is not very essential for AI and pharma, but for longevity is much more. We can extract really value from more advanced architectures. And regarding black box, yeah, so there are various methods and tools to do so. Firstly, kind of every algorithm, it doesn't exist in vacuum, yeah, and it should be validated and checked by experts firstly, and it should be validated by real results which are proven by the market. And we can develop really advanced tools, but without validation from the market, namely without financial indicators that allow us to see that, okay, this deal was successful, this deal was not successful, it cannot be done. So basically, two main tools to prevent this are validation by experts and validation by financial data. And also kind of when we apply both deterministic models and deep neural networks and just polynomial mathematical formulas, which are completely can be comprehended and understandable by humans and by experts, and only in the case only for the enhancement we use deep learning. So the main part of our algorithms is kind of constructed and created by humans.
Okay. Well, thank you for that, Ihor.